Okay, let's talk about hypergeometric probability. So this is another chapter 4 problem where we talked about binomial probability, we talked about Poisson probability. Today we're going to talk about hypergeometric probability. So it's like binomial. Hypergeometric is like binomial probability in that we look for the probability of x successes in n tries. So we're still going to have an x and an n, just like in binomial probability. The difference is that in binomial probability there's a p, the probability of success on each trial, that is constant on every trial. So whereas in hypergeometric probability there is no p because the probability changes from trial to trial as you remove or as you continue searching. As you open containers and look in them, that changes the probability that you'll find something in the next container. So here's an example. We've got 100 shipping containers. So it's something like, we've got a whole bunch of shipping containers here, 100 of them. And we've got a tip that 5 of those 100 containers have people hidden in them. So, maybe in this container, this container, this container, there's 5 out of the 100 shipping containers that have people in them. We only have time to search 20 containers. What's the probability that we will find 3 containers that contain people, that have people in them? So we want the probability that 3 will have 3 successes in the 20 containers that we search. So this is going to be x successes in n tries again, okay? So x is the number of successes, little n, and this is a lowercase n, is the number of tries. So we're going to look in 20 containers. We have 100 containers to search though if we wanted to, but we can only check 20 of them. So the biggest number is going to be capital N. So that's going to be the number of hiding places. And for our example, that's going to be 100. There's 100 hiding places. That's the capital N. The number that we search is going to be lowercase n. That's going to be 20. And then the other thing that we need to know is how many things are hidden. And that is 5. And we're going to call that R. So that's going to be the number of things hidden. So we have 4 variables here, which makes this a little bit more of a difficult probability problem. In binomial probability, there are 3 numbers you need to know: little n, little x, and p, probability of success on one trial. Hypergeometric, there's 4 numbers that you need to know. Capital N, which is the number of hiding places. R, which is the number of things that are hidden in those hiding places. X is going to be how many things we're going to find. That's going to be our number of successes. And little n, which is how many places we're actually going to search. So we want to know the probability of 3 successes in 20 searches. We're going to open 20 shipping containers. Okay, out of the 100. All right, so the way you find this is, it's a hypergeometric formula. It's on your formula sheet, and it is R choose X times, well, let's do the bottom first. So on the bottom, we're going to put how many different ways we can open the 20, where there's 100 things to search, we're going to search 20 of them. How many different ways we can do that is going to be capital N choose little n. So the bottom is how many different ways we can, search. And then up here we want to find, there's R things to find, and we want to find X of them. And then over here we're going to have, this is going to be our successes over here, X successes. And that means we're going to have N minus X failures. This number here is going to be how many things we might not find is going to be N minus R. So binomial probability, or hypergeometric probability, is this formula here. It's on your formula sheet. So R is the number of things hidden, X is the number that we're going to find. Big N is the number of places to hide. Little n is how many we're actually going to search. These two numbers have to add up. So the second number on top and the second number on top here have to add to little n. The first number on top here and the first number on top here have to add to capital N. So I always check that to make sure the first two numbers add up to the first number on the bottom. The second two numbers on top add up to the second number on the bottom. So what we want to know is we've got 5 things hidden, and we want to know the probability we find 3 of them. The denominator is going to be there's 100 places to hide things, and we're going to search 20 of them. So how many different ways can we open those 100 containers? It's going to be 100, choose 20. The top, this is going to be how many things are hidden. That means 95 out of the shipping containers don't have things in them. So remember, these two numbers have to add up. 5 and 95 have to add up to the first number down here. These two numbers, the second number, have to add up this. So if we find 3, we're going to open 20 containers. 3 of them are going to have people in them. That means 17 will not have people in them. So these two numbers have to add up also. So you do this on your calculator. There's big, combination. You use the NCR button on your calculator. So I'm going to type in 5NCR3 times 95 NCR17 divided by 100 NCR20, and then equals. Okay? So that's what you're going to type into your calculator. So let's see if I can do this. 5 NCR3 times 95 NCR17 divided by 100 NCR20. And I'll put that in memory, and that turns out to be 0.047. So this whole thing here is 0.0478, 0.0478. So if I'm making a table, of probabilities, that would be the probability. We could find no shipping containers, 1, 2, 3, 4. We can't get more than 5 because there's only 5 containers that have people. So this, X here can start at 0. We can have no successes and go up to 5. What we found was the probability of 3, which is 0.0478. Okay? And you could fill in these others, using the same thing. So if I wanted to find the probability of 2 containers having people in them, I would scroll over and make this 3 into a 2, and make the 17 into an 18. So this 3 becomes a 2, this 17 becomes an 18. So what this means is 2 of the containers have people in them, 18 do not. And then you just hit, so I changed that to an 18, and nothing else changes, so I made this into a 2, and I made this into an 18, but everything else stays the same. So the probability that 2 out of the 20 containers we open have people would be 0.2073. So this would be 0.2073. So you can, anyway, you can find out all those probabilities just by changing these two numbers in the hypergeometric probability formula. All right, so that's hypergeometric probability.